Hi everyone, welcome to Cognify. In today's session, we'll be tackling two questions, equations and inequalities and algebraic equations. So for both questions, we're going to be solving for x, and we're going to be taking different approaches, testing out our solutions to see if they're correct. And yeah, let's begin. So in the first question, we have a function defined as x plus 6. Okay, so basically square roots here. And then we equate that to x. So now we are told to remember to check for extraneous solutions. So now let us go ahead and solve this. So we can't simply transpose our x and go the normal way of solving this. So we'll need to do a bit of transformation. So we can do this by getting rid of the square root. And to do that, we can simply square root both sides. Okay. So what you do on one side, you do on the other side as well. So now our solution here, not solution, but in the next step, once we've square rooted both sides, our equation then simplifies to x plus 6 is equal to x squared. So now in this format here, it's easier to break this down and solve for x. Okay. The normal approach would be to get everything on one side, right? And then get it in a factorized form and then derive the solutions. So let us transpose x and 6 to the other side. Okay, so it's going to be 0 is equal to x squared minus x minus 6. So now we've got everything on one side. So now we can derive our solutions. So the next step here would be to break it up into factors, right? So there's a simple approach you can use here. This can apply to any quadratic quadratic equation that's given to you, right? Which whose solutions are whole numbered integers. Okay. So firstly, we need to get our constant values, right? So we take a, okay, which is 1, and we take c, okay, and don't worry about the sign. So c is 6. So we put it on top here, 1 and 6. From here, we get factors of both constants. So for 1, it's 1 and 1. For 6, it could be 6 and 1, 3 and 2. So for this example here, right, we look at what the constant in front of x is, right? So our constant there is what? Our constant there is 1, right? Or minus 1. So now what I need to do here is, right, when I break this down, those factors, when I cross multiply and then add them up, right, I need to get 1. So I'll put that 1 here. Okay. So now the numbers here, right, we're going to be adding them up. So now let me show you with two examples, right? Let's say we take factors of 6 as 6 and 1. Okay. And another example where we take it as 3 and 2. Okay. So let's see here, right? So before I forget, let me just add a negative there. Okay, so for this particular part here, we need to include the sign. So now let's see, right? So we're gonna try out both of them, right? So let us cross multiply. 1 times 6 is 6. 1 times 1 is 1. When we add up these two numbers, what do we get? 6. They're both positive, right? So 6 plus 1. Okay, so 6 plus 1 is 7, which is not equal to minus 1. Then the next approach, okay? is to cross multiply these ones. 1 times 2 is 2, and 1 times 3 is 3. One thing to note here, right? When you have these numbers here, you can assign either positive or negative, which at the end will give you -1, which I'll show you in this example here, right? I didn't use it in the previous one because it wouldn't apply. So you see here, right, we've got 3 and 2. If we add them up, 3 and 2, we get 5, okay? But the other approach is to assign a negative to the 3 and a positive to the 2. So -3 plus 2 is -1. In the above example, if we were to assign either negative or positive, we wouldn't get -1 because these two values, the difference is 5. With this example here, the difference is 1, only if we assign a negative to one and a positive to the other. So I might be complicating this enough, but I just wanted to show you a breakdown of this. Okay, that way you can understand how to derive these factors. So now we understand that this one is the right one, right? We've got -3 and +2. We can then just transpose these signs. So minus there and a positive there. Okay, so if we take this part here, right? And then rewrite it here neatly with the x included, right? Because the x here is going to be attached to this part here, to this portion. Okay, well, you got factors of 1. So now, what do we have here? We'll have x minus 3, okay? And then x plus 2. But then we equate it to 0. Okay, so this is basically from here. So now we can find our solutions, right? X is equal to +3 or x is equal to -2. Before we continue, right, we need to confirm these solutions because there are cases where when you substitute your solution, right, the output does not look correct, okay? So we're just going to test it out now and see if that applies here. Because of this here, we're going to remember to check for extraneous solutions. So the only way to confirm that is to substitute the solutions that we've derived. So we got our two solutions, x is 3 and x is -2. Okay, so let us see here, right? Because if we check here, we already have also, what is it? One of the option here, right? It correlates with the solutions that we've gotten here. But it's good to confirm first, right? Before concluding. So our equation is that, right? So we're going to use that. So the left hand side is equal to x plus 6. Okay. And according to this here, the left hand side is equal to the right hand side. So we want to check if that is the case. Okay, the right hand side is equal to x. So now let us see, right? We're going to test out both of them. So for x is equal to 3, the left hand side is equal to 3 plus 6. Okay, the square root of that is 3. Now, with the right hand side, we get 3, right? So we can see here that with this one, it checks out. Now let's check with our other solution, x is equal to -2. We can already tell here that this cannot be possible because the output from a square root never gives you a negative, right? Otherwise, that solution is not defined. But let us write that down and see for ourselves. So here, let's substitute, right? -2 plus 6. -2 plus 6 is 4. Square root of 4 is 2. But on the right-hand side, we get -2. You see, the left-hand side is 2, but the right-hand side is -2. So this solution here does not apply. So what we can do is we can exclude that solution. So we can conclude that x is only equal to 3. and not equal to minus 2. So we discard that other solution. So the only correct option here is. So that's why it's good to test out your solutions, okay? Especially when it comes to cases where you've got a square root, okay? Because the claim here is with the solution as x is equal to minus 2, right? That is telling us that the right-hand side is minus 2. So now the left-hand side cannot be negative, right? And that should be, like, from the start, you should be able to realize that, okay? But sometimes it's good to expand on it by substituting those solutions just to show your workings, okay? But anyways, that is basically it for question 1. Let us go to question 2. So, let me just. Okay, so in question 2, what do we have here? We've got x minus the square root of x minus 1 equal to 3. So we take a similar approach here. Okay, so firstly, we need to square root both sides. But when square rooting both sides, you need to consider what terms you have, right? So if we were to square root this part here, like, we're going to be having a long list of terms. There might be some complications down the line, right? So let us transfer one term to the other side, okay? So we'll have minus square root x minus 1. So this term we leave it on the left, and on the right we transpose x to the other side. So 3 minus x. So let's just divide both sides by a negative, okay, just to make it look a bit more neat. So we have x minus 1 is equal to x minus 3, okay? So I simply divided every term by negative. You see here, for this term here, it becomes a positive. This term here becomes a positive, and this term becomes a negative. So now we can take a similar approach here, right? By squaring both sides, left-hand side and the right-hand side. So now once we've squared, we can then get our equation in a neater format, right? Or simplified format. So now here we'll have x minus 1. So we've gotten rid of the square root. And on the right-hand side, just going to be expanding open the terms, right? So we're going to have x squared minus 6x plus 9. And then the next step, we want to transpose everything on one side, right? So now what we're going to have here? So we'll transpose this to the other side. So we'll have 0 is equal to x squared minus 6x minus x plus 9 plus 1. Okay, so this x becomes a negative and this one becomes a positive. So anytime you transpose a term over the equal to sign, its sign changes. So let's see. Let us continue here. Okay, so let's see. So let us simplify it, right? So it's going to be x squared minus, so we're going to be adding up the like terms. Minus 6x minus x is minus 7x. Plus 9 plus 1 is plus 10. And then equated to 0. So what you'll notice is that I flipped this around, right? So it doesn't affect the sign. So I just reorganized it, okay? Just to make it easier to work through it, right? Because I have a habit of having the terms on the left side and then the 0 on the other side. But just note that I haven't changed anything. Okay, so now in the next step, we can then factorize it. So you can apply that method I showed previously. You put your constants here, 1 and 10. You find factors of 1, it's 1 and 1. Factors of 10, it's 10 and 1 or 5 and 2, right? So I'll just put 5 and 2. Why? Because when I cross multiply this, right? You see these two terms here, the difference is 3. And we can see here that we can actually use these two numbers here to get to 7, right? By assigning negative to both numbers, okay? Because at the end, what we want is these numbers here, right? When we add them or subtract them, we get -7. Okay, so it's good to try this method out with a couple of them, right? That way it will become second nature to derive these factors. Okay, then, so now let us see, right? So our factors are x minus 5 and x minus 2. We equate that to 0. So x is equal to 5 or x is equal to 2. So we've got two solutions here. Let's just go straight here and see. Okay, but I'll leave it up to you to try and test out, right, if these two solutions are correct. Okay, because we can see there is a square root involved, so there might be something fishy going on. But that will be about it. And yeah, till next time.